Hello there, Santi here. Welcome back to my YouTube channel. Now, if you have been following along with our series, you know we have already conquered 66 easy and medium level questions from Stata Scratch together. That built our foundation. But today we are stepping into final boss arena. In this video, we are taking on the ultimate gauntlet, a 15 question hard SQL marathon featuring real production grade interview prompt from tech giants like Google, Amazon, Stripe, Facebook and Mckinsey. We are going to break down every single advanced design pattern from time traveling lag functions and sliding window frames to complex self joins and org chart hierarchies. Here is the best part. Between our previous 66 strata scratch problems and these 15 hard questions, you will have covered virtually every single logical pattern tested in the tech interviews. You can officially stop hopping from platform to platform because mastering these exact curriculum is everything you need to clear your SQL coding screens. So grab your coffees, pause your compilers, and let's jump straight into question number one. Alright, first I will select all the hard questions from Data Lemur website. Category SQL, difficulty hard. So many of them are of premium category. We are going to solve only the free questions. So let's start with our question number one, active user retention. So first I will read out the question for you. Active user retention. Assume you are given a table containing information on Facebook user actions. Write a query to obtain number of monthly active users in July 2022, including the month in numerical format 1, 2, 3. Hint: an active user is defined as a user who has performed actions such as sign in, like, or comment in both the current month and the previous month. So we are given user actions table. It has columns like user ID, event type, and event date. And here is our example output. So we have to output month and monthly active users in July 2022. So first I will write the pseudocode for this question. First, we open our main select statement, extracting the month 7 and counting the unique user IDs. Second, we lock our main query into July 2022 using the where clause on event underscore date. Third, we add the retention filter and user ID in dot. This tells SQL we are about to cross reference our July users against another list. Fourth, We group by the extracted month to output our final aggregated count. Fourth, okay. So now I will write the code for you. The bulletproof SQL solution. Select extract month from event date as month as month count distinct user ID as monthly active users from user actions where extract month from event date equals to 7 and extract year from event date equals 2022 and user ID in select select user ID from user actions where extract month from event date equals to 6 and extract year from event date equals to 2022. Group by extract month from event date. So I will submit this code. Okay, now I will explain you the solution again. Alright, question number 1 is the infamous Facebook monthly active users problem. Before we have a massive chaotic log of every single click, like and sign in happening every second of the day, happening every second of every day. We need okay we need finally we need a single clean row that tells us exactly how many July users are retained active users, meaning they were also hanging out on the platform in June. Okay, when candidates see compare this month to last month, they instantly panic. The most common mistake here is trying to write a massive self join because users can log in dozens of times a month. A self join will explode into millions of duplicate rows, crashing your query and tanking your interview. We are going to bypass that nightmare entirely by using a subquery as a VIP guest list. Okay, let's build the architecture. First, we write a standard query just to find unique users in July 2022. We select the month using extract. We count the distinct user ID and we lock where close to month 7 and year 2022. If we just stop here, we would just have July's active users, but we need returning users. So here is where we make it bulletproof. Before we close the query, we add and user ID in. Inside those parentheses, we quickly grab all the user IDs from month 6 and year 2022. SQL essentially builds a hidden list of everyone who was active in June. When it evaluates July's users, it checks them against the list. If they are on it, they get counted. If they are brand new user in July, they got rejected. Throw a group by at the bottom and we hit submit. We have perfectly calculated the monthly active users without a single message on. Okay. So in our question we were given that an active user is defined as a user who has performed actions such as sign in like or month in both current month and previous month. So what if an active user is defined as the user who has performed actions such as sign in like and commit in both the current month and the previous month. So a user must have done all these three things to in the previous month and the last month, in the current month and the previous month. So then only he or she will be counted as active. So I will write directly the solution for this since we ourselves have tweaked the question a little. So we would not be able to and submit it and get the right answer. So let's write the solution directly with July super users as select user ID from user actions where extract month from event date equals to 7 and extract year from event date equals 2022 and event type in sign in like comment. Group by user ID having count distinct event type equals to 3 comma June super users as select user ID select user ID from user actions where extract month from event date equals to 6 and event type in sign in like comment group by user ID having count equals to 3. Select 7 as month, count distinct user ID as monthly active users from July super users where user ID in select user ID from June super user from June super users. So alright, I will explain you this code again. Alright, so let's say the interviewer throws a massive curveball. They change one word in the prompt from or to and. Okay, before we just needed to know if someone showed up and did anything. Now we need to verify that a user completed a specific trifecta of actions: signing in, liking, and commenting in both July and previous month. So the biggest trap here is logic based. Beginners will intuitively write where event type equals to sign in and event type equals to like. But think about how a database is structured. A single row is only one event. It is mathematically impossible for a single row to be both a sign in and a like. Like if you write that the query returns blank, you panic and interview is over. We have to zoom out and look into users' total history. Alright, to solve this, we are going to build two VIP lists using CTE. Let's build our July super users list first. We select user ID and filter for July 2022. Then we use our magic weapon. Group by user ID followed by having count distinct event type equals to 3. This tells SQL to look at all the user actions, count the unique types, and only keep the user if they hit all three. We duplicate the exact same block of code for June to create our second VIP list. Now the grand finale. In our main query, we simply hardcode 7 for month, count the users from our July list and use an in clause to check if they were also sitting in our June list. So this will be our right solution if interviewer changes our question a little bit from or to and. Okay, so let's move to our next question number 2. So this is our question number 2, y on y growth rate. Alright, I will clear out the solution first. So y on y growth rate. So I will read out the question first. Assume you are given a table containing information about Wayfair user transactions for different products. Write a query to calculate year-on-year growth rate for total spend for each product, grouping the results by product ID. The output should include the year in ascending order: product ID, current year spend, previous year's spend, and year-on-year growth percentage, rounded to 2 decimal places. So we were given a user transactions table. So here is the example output. It has transaction ID, product ID, spend, and transaction date, and is our example output. We have to output year, product ID, current year spend, previous year spend, and year on year date. So first I will write the pseudo code for this. So let's skip the pseudo code. I will directly write the solution, then I will explain it to you. Okay. With yearly spend as select extract year from transaction date as year, product ID, sum spend as current year spend from user transactions group by extract year from transaction, extract year from transaction date and product ID. So we move to our next CTE, lagged spend as select year, product ID, current year spend, lag current year spend, comma 1 over partition by product ID, order by year, as previous year spend, from yearly spend select year, product ID, current year spend, previous year spend, round current year spend minus previous year spend upon previous year spend into 100 comma 2 as YOY rate from lagged spend order by product ID year. So let me first submit this solution. Line number 8. Okay, so first now I will explain you the solution for this question. So alright. So this is an year on year growth rate problem, and it is a certified classic. So before we have a massive transaction log and random purchases scattered across random dates. We need a beautifully formatted report showing the total spend per product per year and previous year's spend right next to it, and exact percentage growth rounded to two decimals. So here are the two massive interview traps that will crash your interview. Trap number 1: trying to do percentage math using column aliases in the exact same select statement where you created them. SQL cannot read an alias it just made. It will throw an error. Trap number 2: using lag function without partition by. If you just order by date, SQL will grab the previous transaction in the entire database, mixing up the different products. We have to isolate the timelines. So to make our solution bulletproof, we are going to build this in three layers. Layer 1 is our yearly spend CTE. We extract the year, group by product ID, and sum the total spend. This cleans up the raw data so we have exactly one row per product per year. Layer 2 is of lagged spend CTE. This is where we fire up our time machine. We pull in our clean data and we create our previous year spend column using lag current year spend comma 1. But the magic happens inside the over clause. We add partition by product ID. This tells equals, hey, build a separate timeline for every single product. The layer 3 is the grand finale. Because our current and previous numbers are fully locked in our CTE, we just select them in our main query and run the standard percentage math, current minus previous divided by previous times 100. Wrap the entire solution, wrap the entire equation in round function to two decimals, sort it by product and year. Then we hit submit. Okay, we grab the green check mark. So let's move to our question number 3. Question number 3 is this: maximize prime item inventory. So first I will read the question for you. Amazon wants to maximize storage capacity of its 500,000 square foot warehouse by prioritizing a specific batch of prime items. The specific prime product batch detailed in inventory table must be maintained. So if the product if the prime product batch specified in the item category column included one laptop and one side table, that would be base batch. We could not add another laptop without also adding a side table. They come all together as a batch set. After prioritizing the maximum number of prime batches, any remaining square footage will be utilized to stock non-prime batches, which also come in batch set. and cannot be separated into individual items. Write a query to find a maximum number of prime and non-prime batches that can be stored in 500,000 square feet warehouse based on the following criteria. Prioritize stocking prime batches. After accommodating prime items, allocate any remaining space to non-prime batches. Output the item type by prime eligible first followed by non-prime along with the maximum number of batches that can be stocked. Assumption. Again, product must be stocked in batches. So we want to find largest available quantity of prime batches and the largest available quantity of non-prime batches. Non-prime items must always be available in stock to meet customer demand. So the non-prime item should never be zero. The item count should be whole number integer. So we are given an inventory table, inventory example input. It has event ID, event type, it has item ID, item type, item category, and square footage of the item that they will occupy. We have to output item type and the item count. So total how many prime eligible items can be stored in the warehouse and total number of non-prime items type can be stored in the warehouse. Let's continue by writing the solution for this question. So with batch summary as select item type sum of square footage square footage square footage as batch SQFT, comma count item ID as items per batch, count item ID as items per batch, from inventory group by item type, group by item type, group by item type, prime allocation as select item type, comma floor 5 lakhs slash 5 lakhs upon batch SQFT as prime batches floor 5 lakhs 5 lakh upon batch SQFT into items per batch items per batch as item count 500,000 minus floor 500,000 upon 500,000 upon batch square feet, batch SQFT into batch square feet as remaining space, as remaining space from batch summary, where item type equals to prime eligible, comma, non prime allocation, as select s dot item type floor p dot remaining space upon s dot batch square feet into s dot items per batch as item count from batch summary as s, cross join prime allocation as p, where s dot item type equals to not prime, select item type, item count from prime allocation union all, select item type, item count from non-prime allocation. Okay, all right. Question number 4 is a notorious one of question number 3. It was 3, na? Yeah. Question number 3 is a notorious one from Amazon. Maximize prime item inventory. We had a messy list of individual items with specific square footages and some prime, some not. We need we need to figure out exactly how many individual prime and non-prime items we can cram into 500,000 square feet warehouse, prioritizing prime items first, but forcing them to be stocked in exact mathematical batches. So the interview trap. The trap here is overcomplicating the inventory. Beginners will try to write complex window function or recursive loops to pack items one by one. If you do that, the timer will run out. The prompt says that they come in batch sets. You have to stop looking for individual laptops and TVs. Instead, treat the entire Prime catalog as one massive mega box. So, explaining the code. Let's build this in phases. Our first CTE is batch summary. We group by item type and calculate two things: sum of square footages to get the size of mega batch, mega box, and count of item ID to know exactly how many items are tapped up inside it. Now, for the month in our prime allocation CTE, we take our 500,000 square foot warehouse and divide it by prime batch square footage. We wrap it in floor function because we cannot stock half a batch. Simply that by our item count, and we have our total prime items. To find the leftover space, we just subtract the space we just took up from 500,000. Next, we cross join that remaining space into non-prime allocation CTE. We take the leftovers, divide it divide it by the non-prime batch size, floor it, and multiply by batch items per batch. For the grand finale, we just write a clean union all to stack our prime item count on top of our non-prime item count. When we hit run and submit, okay, we have just solved a massive supply chain math problem using pure SQL. Let's move to our next question. Question number 4. Median Google salary, Google search frequency. Median Google search frequency. So let's read our question. Median Google search frequency. Google's marketing team is making a Super Bowl commercial and needs a simple statistic to put on their TV ad: the median number of searches a person made last year. However, at Google scale, querying the 2 trillion searches is too costly. Luckily, you have the access to the summary table, which tells you the number of searches made last year and how many Google users fall into that bucket. Write a query to report median of searches made by user. Round the median to one decimal point. Okay, we are given a search frequency table. It has searches and number of users who done that searches. For example, one search was done by two users, two searches were done by two users. So we need to find the median of number of searches made. Alright, so I will write the solution first, then I will explain you the code. So we write with expanded searches as select searches from search frequency, cross join generate series num1 number of users, select round percentile count 0.5 within group order by searches numeric 1 as median from expanded searches. So alright, let's get into question number 4 from Google. This is the median search frequency problem. Okay, before we have a compressed summary table. Instead of billions of rows, it just says two people searched two times. After we need to find the exact median, the literal middle value for all those searches rounded to one decimal. The interview trap. The trap here is the definition panic. Under pressure, candidates forget the difference between average and a math and then try to write a crazy math formulas multiplying the column together. The interviewer is waiting for you to do that so that they can fail you on the basic statistics. A median requires the data to be perfectly ordered in single line. You cannot find the middle of the compressed table without unpacking it first. Explaining the code. Let's break down our let's break down let's break out the unboxing knife. We are going to build an expanded searches CTE using one of the most powerful functions in PostgreSQL, generate series. By writing cross join generate series 1 comma num users, SQL takes our compressed frequency table and unzips it. If a bucket says 4 users, the SQL splits out 4 identical rows. Now that our data is lined up flat on the table, the main query is a joke. We just use SQL's built-in 50th percentile function, percentile count 0.5 within group order by searches. This physically points to the dead center of our expanded data. To make Google happy, we cast it to a numeric type, wrap it in round function to exactly one decimal place, and we are done. When we hit submit, oh, syntax error at or near with line number 8. Within group by. When we hit submit, our solution is our solution is accepted. So we move to our next question. Question number 5, advertiser status. So advertiser status. You are provided with two tables. The advertiser tables contains information about advertisers and their respective payment status. The daily pay table contains current payment information of for advertisers, and it only includes advertisers who made the payment. Write a query to update the payment status of Facebook advertisers based on the information in daily pay table. The output should include the user ID at their current payment status, sort, sorted by the user ID. The payment status of advertisers can be classified into following categories. New. Advertisers who are newly registered and have made their first payment. Existing. Advertisers who have made payments in past and have recently made a current payment. Churn. Advertisers who have made payments in past but have not made any recent payment. Resurrect. Advertisers who have not made a recent payment but may have made a previous payment and have made a payment again recently. Before proceeding to the question, it is important to understand transactions, the possible transitions in advertiser status based on the payment status. The following table provides a summary of these transitions. Current status new, updated status existing, paid on date T, paid, not paid. Current status column represents the advertiser's current status. Payment status column represents the updated payment status based on the condition. Payment on date T column indicates whether the advertiser made a payment on a specific day or not. Okay. The transitions between payment status is provided in the provided table can be summarized as follows. Row 2, 4, 6 and 8. If an advertiser doesn't make a payment on date T, regardless of their previous status, their payment status transitions to churn as the updated status. Rows 1, 3, 5, 7. If an advertiser makes a payment on date T, the status is updated to either existing or resurrect based on their previous status. If the previous status was churned, the updated status is resurrect. For any other status, the updated status is existing. So we are given in two tables. First table is advertiser table. It has user ID and their status, and daily pay table. It has user ID and how much money they have paid in this. So we have two. So here is our example output. We have to output user ID and their new status. Okay. So it's a really hard problem. Now I will first write the solution for this problem. Select coalesce a dot user ID comma d dot user ID as user ID case 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 when d dot paid is null, then churn when a dot status is null, then new when a dot status equals to churn, then resurrect resurrect else existing and as new status. from advertiser as a full outer join daily pay as d on a dot user id equals to d dot user id order by user id. All right, so question number 5 is Facebook advertiser status, and this one is a psychological test. We have an historical. Okay, we have an historical list of advertiser status and a daily log who paid today, and an absolutely terrifying 8-row matrix of business logic. We need a single cleanly updated list of every advertisers and their brand new status for tomorrow. Okay, the interview trap. In your mind you went just in your mind you just went completely blank reading this question. You are not alone. The interviewer throws this massive transition matrix at you to induce pain. Beginners will try to write 8 different when statements. Even worse, they will use a standard left join, which completely deletes brand new advertisers who made the first payment today. We have to use full outer join and compress that matrix. Let's break the matrix. We start our we start our query and immediately jump to the from clause. We use a full outer join between advertisers and daily pay. This grabs absolutely everybody. Because we have a full outer join, users might not exist in one of the tables. So in our select statement we use coalesce a dot user id comma d dot user id to flawlessly grab that id no matter which table they came from. Now we deploy our case when statement to collapse that 8 rules into 4. Think about it logically. Did not pay today. When d dot paid is null, then churn. Did you pay today? But you have no history. Did you not pay today? Okay. Did you pay today but have no history? When a dot status is null, then new. Okay. Did you pay today but your last status was churned? When a dot status equals to churn, then resurrect. You literally made other scenario where you made a payment for literally every other scenario where you made payment else existing. Close the case statement. Throw an order by user ID at the bottom, and you just turned a nightmare business logic problem into a completely bulletproof query. When we submit our solution, it is accepted. Okay, we move to our next question. Question number 6. Consecutive filing years. Consecutive filing years. Intuit, a company known for its tax filing products like TurboTax, QuickBooks, offers multiple versions of these products. Write a query that identifies the user IDs of individuals who have filed their taxes using any version of TurboTax for 3 or more consecutive years. Each user is allowed to file taxes once a year using a specific product. Display the output in ascending order of user IDs. So we are given a file taxes table. It has 4 columns: filing ID, user ID, filing date, and product which they have used. Here is our example output. We have to output the user ID of the individuals who have filed their taxes using any version of the TurboTax for 3 or more consecutive years. Okay. So let's move to the solution with TurboTax years as select distinct user ID, extract year from filing date, as filing year, from filed taxes where product like TurboTax percentage, comma, consecutive check as select user ID, filing year, filing year, comma, lag filing year, comma, 1 over partition by user ID, order by filing year as previous year 1, lag filing year 2 over partition by user ID, order by filing year as previous year 2, from TurboTax years. Select distinct user ID from consecutive check, from consecutive check where filing year equals to previous year 1 plus 1 and filing year equals to previous year 2 plus 2 order by user ID. Alright, so let's keep the momentum rolling with question number 6 from Intuit. Consecutive filing years. Okay, we have a messy log of tax filings with a bunch of different products name and product and random dates. We need a clean ordered list of highly loyal users who have filed with any of the version of the TurboTax for at least 3 consecutive years in a row. The first trap, the interview trap. The first trap here is the product name string matching. The Intuit is testing if you know how to use percentage wildcard to drop TurboTax Online, TurboTax Desktop, all of it, TurboTax Deluxe, etc. The second trap is the word consecutive. If you try to use a simple having count greater than equal to 3, you are going to fail. That just checks if they have filed 3 times ever, not if if they filed 3 years in a row. To check consecutive years, we need to bring back our secret weapon from question number 2, the lag time machine. Pattern recognition is everything in these interviews. Let's build the exact same problem. Let's build this. First, we create our TurboTax years CTE. We select distinct user ID and extract the filing year. We add our crucial where product like TurboTax percentage filter. Now we have a completely clean timeline of who filed when. Next, we fire up the time machine in our consecutive check CTE. We use lag filing year 1 to look at their previous filing and lag filing year 2 to look at one before that. We strictly partition by user ID so we don't accidentally mix up two different people's taxes. The grand finale is simple. We select our distinct user ID where the current filing year is exactly equals to previous year plus 1, previous year 1 plus 1 and previous year 2 plus 2. Throw an order by user ID at the bottom and we hit submit. We just proved to the interviewer that our logic is consistent and bulletproof. So we move to our next question. Question number 7. Marketing touch streak. So here is our question number 7, marketing touch streak. As a data analyst on slow as a marketing as a data analyst on Snowflake's marketing analytics team, your objective is to analyze customer relationship management data to identify contacts that satisfy two conditions. Contacts who made a marketing touch for Contacts who had a marketing touch for 3 or more consecutive weeks. Contacts who had at least one marketing touch of the type trail request. Marketing touches, also known as touch points, represents the interactions or points of contact between brand and its customers. Your goal is to generate a list of email addresses of these contacts. We are given a marketing touches table, and here is the example input: event ID, contact ID, event type and event date, and the CRM contacts table which has contact ID and their email ID is our example output. Okay, we need to find the contacts who satisfied all the two conditions. So I will write the solution for this question. With weekly touches as select distinct contact ID, date trunk, week, comma event date as touch week, from marketing touches consecutive weeks as select contact ID touch week, lag touch week, comma 1 over partition by contact ID, order by touch week has previous week 1, lag touch week, comma 2 touch week, comma lag touch week, comma 2 over partition by contact ID, order by touch week as previous week 2, from weekly touches streak contacts as streak contacts as select distinct contact ID, select distinct contact ID from consecutive weeks where touch week equals to previous week 1 plus interval 1 week, and touch week equals to previous week 2 plus interval 2 week 2 weeks. Select distinct c dot email from streak contacts as s as join marketing touches as m on on s dot contact id equals to m dot contact id. Join crm contacts as c on s dot contact id equals to c dot contact id, where m dot event type equals to trial request. trial request Yeah, our solution has been accepted. All right, let's tackle this absolute beast from Snowflake, marketing touch streak. Okay, we have a chaotic CRM log full of webinars, downloads, and trial requests happening at the random times, plus a separate table of contact emails. Okay, we need a clean targeted email list of users who meet two strict conditions. They interacted with us for 3 consecutive weeks, and at least one of their interactions ever was a trial request. Okay, when candidates start this problem, they usually make two massive mistakes right out of the gate. First, they join the email table immediately. Do not do that. That slows down your query by attaching data into thousands of rows that will end up being thrown away anyway. Second, they try to check for consecutive weeks on raw data. If a customer did three things in week 1, your query sees 3 rows and thinks they hit a 3 week streak. We have to deduplicate the timeline first, explaining the code. Let's build this cleanly using CTEs. Phase 1 is our weekly touches table. We grab the contact ID, use date trunc week, event date. By adding select distinct, we wipe out the duplicate noise. Whether a user did one thing or 50 things this week, they get exactly one row. Phase 2 is where we deploy the time machine. In our consecutive week CTE, we use lag touch week 1 and lag touch week 2, making sure we partition by contact ID so we don't mix up different customers' timelines. Phase 3 is simple maths. In context tree, we filter for rows the correct where the current week equals to previous week plus 1 week and previous week 2 plus 2 weeks. If our maths evaluates to true, we have found our 3 week streak. Finally, the grand finale. We take this exclusive list of streak hitters, join them back with marketing touches, where event type is strictly a trial request, and join to CRM contacts to pull their email. Add a select distinct at the top so we don't spam anyone with multiple emails. When we hit submit and our solution is accepted, so we start our next question. Question number 8. 3 topping pizzas. Alright, I will start with I will first read out the question. 3 topping pizzas. You are a consultant for a major pizza chain that will be running a promotion where all 3 pizza toppings will be sold for a fixed price, and they are trying to understand the costs involved. Given a list of pizza toppings, consider all the possible 3 topping pizzas and print out the total cost of 3 toppings. Sort the results with the highest cost of the top, followed by the pizza toppings in ascending order. Break ties by listing the ingredients in uh, alphabetical order, starting from first ingredients followed by second and third. Be careful with spacing or lack of between each ingredient. Refer to our example output. Notes: do not display pizzas where topping is repeated. For example, pepperoni, pepperoni, onion pizza. Ingredient must be listed in alphabetical order. Okay, we are given a pizza toppings table. It has 2 columns: toppings name and ingredient cost. Here is our example output. We have to output the 3 pizza toppings and their total cost. Okay, so I will write the solution for this question first. Select concat p1 dot topping name comma comma p2 dot topping name comma p3 dot topping name as pizza p1 dot ingredient cost plus p2 dot ingredient cost plus p3 dot ingredient cost as total cost as total cost from pizza toppings as p1 inner join pizza toppings as p2 inner join pizza toppings as P2 on P1 dot topping name is less than P2 dot topping name. Inner join pizza toppings as P3 on P2 dot topping name is less than P3 dot topping name. Order by total cost in descending order. Pizza in ascending order. We hit submit. Yeah, our solution is accepted. Now I will explain you the code that I have written. Alright, so it is our question number 1 2 3 4 5 6 7 8. So yeah, so question number 8 is Mckinsey 3 topping pizzas. Before we have a simple flat menu, table listing individual pizza toppings and their individual costs. We need to generate a comprehensive master menu for every single unique 3 topping pizza combinations possible. Calculate the total price of each pie. Sort them from most expensive to least expensive. The interview trap. The biggest trap in this interview is the permutation explosion. When beginners try to combine in SQL, they intuitively use not equal operator to make sure pizza doesn't have pepperoni twice. But if you do that, SQL will generate pepperoni, onion sausage, and onion sausage pepperoni. You will end up with thousands of duplicate pizzas. Your output will be rejected, and you will spend rest of your interview trying to write messy deduplication code. So, explaining the code, we are going we are going to completely bypass that mess using an absolute gem of a SQL trick, string inequality. We start by joining our pizza toppings table to itself 3 times, aliasing them as P1, P2 and P3 for our 3 slices on the pie. But look closely to our join conditions. Instead of not equal, we write on P1 dot P1 dot topping name is less than P2 dot topping name and P2 dot topping name is less than P3 dot topping name. Why does this work? Because in SQL, the less than sign evaluates alphabetical order. By forcing P1 to be alphabetically less than P2 and P2 less than P3, it is mathematically impossible for an ingredient to repeat, and it is impossible to generate the same pizza twice. Chicken will always come before onions, and onions will always come before sausage. Now, our select statement is a breeze. We just concat our 3 toppings together separated by commas. Add the 3 ingredient cost columns together with plus sign and order by total cost in descending order. Okay, we when we hit submit, we just solved a high level Mckinsey combinations problem with zero math functions and pure SQL elegance. So here is our ninth question: patient support analysis. Alright, let's start with question number 9. Question number 9 is patient support analysis part 3. It was asked by United Health. So first I will read out the question for you. Patient support analysis part 3. United Health Group UHG has a program called Advocate for Me, which allows policyholders or members to call and advocate and receive support for their healthcare needs. Whether that's claim and benefit support, drug coverage, pre and post authorization, medical records, emergency assistance, or member portal services. Write a query to obtain the number of unique callers who made the calls within 7-day interval of their previous call. If a caller made more than 2 calls within the 7-day period, count them only once. Okay, we are given a callers table. It has following columns like policy holder ID, case ID, call category, call date, and duration, call duration. We have to output the policy holder counts who made calls within a 7-day interval of their previous calls. So first I will write the SQL solution for this question with lagged calls as with lagged calls CTE as select policy holder ID, call date, lag, call date, comma 1 over partition by policy holder ID order by call date as previous call date from callers. Now we move outside the CTE. We write our main query, select count distinct policy holder ID as policy holder count as policy holder count from lagged calls where call date minus previous call date is less than equals to interval 7 days. So now I will explain you this code. Alright, we start with our question number 9 from United Health Group patient support analysis. Before, we have a massive call center log with timestamp, call duration, and patient IDs scattered all over the place. We need a single number telling us how many unique patients called back within a 7-day window of their previous phone call. The interview trap. The biggest trap in this question is pure psychological. Look at the sentence in the prompt. If a caller made more than 2 calls within the 7 days period, count them as once. When the beginners read that under pressure, They panic and try to write complex case when statements or subqueries to track calls counts per week. Do not fall for it. That entire sentence is just the interviewer's fancy way of telling you to use count distinct. We do not have to use complex math. We just need our favorite window function pattern explaining the code. Let's build our lagged call CTE to know if a patient called back within 7 days. We have to look at their current calls and their previous call at the exact same time. We grab policy holder ID and call date, and then we use our time machine lag call date comma 1. We must partition by policy holder ID and order by call date so that we are only ever looking at the chronological call history of one individual patient at a time. Now our data is perfectly lined up. We have the current call timestamp in the column A and previous call timestamp in column B. In our main query, the filtering logic is effortless. We just need where call date minus previous call date is less than equals to interval 7 days. If they call back within a week, they survive the filter. If they waited for a month, they get dropped. To finish it off and satisfy that scary count them only once rule, we just apply count distinct policy holder ID to our filtered rows. It automatically deduplicates our frequent flyers, giving us the exact patient counts in just 11 lines of code. When we hit submit, our solution is accepted. Now we move to our next question number 10. Patient support analysis part 4. This question was also asked by United Health Group. Okay, so first I will read out the question for you. United Health Group has a program called Advocate for Me. So first I will read out the question number 10 for you. United Health Group UHG has a program called Advocate for Me, which allows policyholders or members to call an advocate and receive support for their healthcare needs, whether that's claim and benefit support, drug coverage, pre and post authorization, medical records, emergency assistance, or member postal services. To analyze the performance of the program, write a query to determine month over month growth rate specifically for long calls. A long call is defined as a call that is lasting for more than 5 minutes or 300 seconds. Output the year and month in numerical format and chronological order along with the growth percentage rounded to one decimal place. We are given a callers table and here is the example input. We have columns like policy holder ID, case ID, call category, call date and call duration. We need to output the year, month and long call growth percentage. So first I will write the solution for this. Select, no, first I will make the CTE with monthly long calls as select extract year from call date extract year from call date as YR as yr, comma, extract month from call date as mth, count case id as current month call, current month calls from callers where call duration seconds is more than 300, group by extract year from call date, month from call date. Extract year from call date, month from call date, comma, lagged calls as lagged calls as select year, month, current month calls, lag current month calls, comma 1 over order by year, month, as previous month calls, from monthly long calls, select year, mth, round, current month calls minus previous month calls, numeric, upon previous month calls into 100, comma 1 as long calls growth percentage from lagged calls, order by year, mth. So I will explain you this question. Okay, so this is question number 10 from United Health Group, patient support analysis part 4. Before, we have a massive call center log with timestamp and duration in seconds. We need a clean, chronologically ordered report showing the exact month over month percentage growth rate specifically for long calls. defined as any call lasting for more than 300 seconds. The interview trap. If you have been following along with our marathon, your pattern recognition should be tingling right now. This is the same architecture as question number 3, but there is a major trap candidates fail into: over partitioning. In previous problems, we used partition by inside our lag function to separate products or users. If you try to partition by year or month here, you will break the timeline and get nulls every January. Because we want total company growth, we must leave the window unpartitioned and simply order by time. Also be aware of integer division. In PostgreSQL, dividing two integers drops the decimal. You must cast to numeric before dividing. Explaining the code. Layer 1 is our monthly long call CTE. We extract the year as YR and month as MTH and count the cases. But before we group, we add our crucial filter where call duration seconds is greater than 300. This instantly cleans out all the quick check-in calls, so we are only summarizing true long calls. Layer 2. Layer 2 is where we deploy the time machine. In our lagged call CTE, we pull in our current month's count and we create previous month calls using lag current calls, 1. Look at the over clause. Over order by year, month. No partition needed. SQL lines up every month in company's history in chronological order and flawlessly reaches up one row to grab last month's numbers. The layer 3. Layer 3 is just simple percentage math. We take current minus previous, cast it to numeric, divide by previous and multiply it by 100.0. Wrap it in round function set to one decimal place. Order by year and month. When we hit submit, our solution is accepted. Now we start our question number 11, repeated payments. Question number 11, repeated payments. Sometimes payment transactions are repeated by accident. It could be due to user error, API failure, or just a retry error that causes credit card to be charged twice. Using transactions table, identify any payments made at the same merchant with the same credit card for the same amount within 10 minutes of each other. Count such repeated payments. Assumption: the first transaction of such assumption the first transaction of such payment should not be counted as repeated payments. This means if there are two transactions performed by a merchant with the same credit card for the same amount within 10 minutes, there will only be one repeated payment. So we are given a transactions table. It has many columns like transaction ID, merchant ID, credit card ID, amount and transaction timestamp. We have to output the payment count that were made to same merchant from same credit card for the same amount within 10 minutes of each other. So I will write the SQL solution now. With lagged transactions as select merchant ID, credit card ID, amount, transaction timestamp, lag, transaction timestamp, 1, transaction timestamp, 1, over partition by merchant ID, credit card ID, amount, order by transaction timestamp, as previous timestamp, from transactions, select count merchant ID as payment count from lagged transactions where transaction timestamp minus previous timestamp is less than equals to interval 10 minutes. Alright, question number 11. This is a real fintech problem from Stripe called repeated payments. So before, we have a massive transaction log with millions of credit card swipes happening every second. We need to build an automated glitch detector that catches any identical payment, same card, same merchant, same price, that accidentally occurred within 10 minutes of a previous swipe. The interview trap. Now let me show you the code I wrote on my first attempt. Okay, the interview trap. Look at so I will explain you the code directly. Explaining the code. Let's build our lag transaction CTE. To catch a double charge, we need to compare the current swipe to the previous swipe. We select merchant ID, credit card ID and amount. Then we bring in our favorite tool, lag transaction timestamp, 1. Here is the magic in our over clause. We write partition by merchant ID, credit card ID and amount. Order by transaction timestamp. This builds an isolated timestamp for every unique purchase combination. If a card is swiped twice for the same amount at the same store. SQL places those timestamps right next to each other in our table. In our main query, filtering is effortless. We just write where transaction timestamp minus previous timestamp is less than equals to interval 10 seconds. Because we use lag, this strictly isolates the second swipe, the accidental duplicate, without flagging the original valid purchase. Wrap it in our count. Hit submit. Okay, there is a syntax error in line number 16. Transaction timestamp minus previous timestamp. When we submit our code, it is flawlessly accepted. Now we start our question number 12. Reactivated users from Facebook. So here is our question number 12. First I will read out the question for you. Imagine you are provided a table containing the information about user logins on Facebook in 2022. Write a query that determines the number of reactivated users for a given month. Reactivated users are those who were inactive the previous month but logged in during the current month. Output the month in numerical format along with the count of the reactivated users. Here some important assumptions to consider. The user login tables only contains the data of year 2022 and there are no missing dates within that period. For instance, if a user whose first login date is of March 2022, we assume that they have previously logged in during the year 2021. Although the data from their previous logins is not present in the user logins table, we consider these users as reactivated. So we are given a user logins table. It has two columns, user ID and login date. We have to output the month and reactivated users in each month. So first I will write the SQL solution for this with monthly logins as select distinct user ID extract month from login date as login month as login month from user logins comma lagged logins as select user ID login month lag login month comma 1 over partition by user ID order by login month as previous month From monthly logins, select login month as MTH, count user ID as reactivated users. From lagged logins, where previous month is null and login month is greater than 1, or login month minus previous month is greater than 1. Group by login month, order by login month in ascending order. So now I will explain you this code. Alright, question number 12 is a classic from Facebook, reactivated users. Before, we have a massive chaotic log of every single timestamp when a user opened the Facebook app in 2022. After, we need a clean monthly report showing exactly how many zombie users came back to the platform after being completely inactive for at least 1 month prior. Alright, I will explain you this code now. Layer 1, our monthly login CTE. We use select distinct user ID and extract the month. Where a user logged in once or 100 times in March, they get exactly 1 row. Layer 2, the time machine. In our lagged login CTE, we pull in the previous month using lag login months, 1, making sure to strictly partition by user ID so we don't mix up the different people's accounts. Layer 3 is where we deploy our bulletproof filter. We want rows where login month minus previous month is greater than 1, meaning there is a mathematical gap of 2 or more months between visits. To catch the users who went silent at the end of 2021, we finally come back and add or is null or previous month is null and login month greater than 1. This flawlessly grabs returning users while protecting January's consecutive baseline. We group by month, count the users, sort ascending and hit submit. Okay, line number 13. Order by partition by user ID. Order by login month. And our solution has been accepted. So we move to our next question, question number 13. Senior managers by Google. Senior managers, Google SQL interview questions. Assume we have a table of Google employees with their corresponding managers. A manager is an employee. A manager is an employee with a direct report. A senior manager is an employee who manages at least one manager. But None of their direct reports is a senior manager themselves. Write a query to find senior managers and their direct reports. Output the senior manager's name and count of their direct reports. The senior manager with the most direct report should be the first result. Assumption: an employee can report to two senior managers. Okay. So we are given an employees table and here is the employees input out. Alright, we were given an employees table. It has columns like employee ID, manager ID and manager name. We have to output the managers who are senior managers and number of total direct reportees under them. So I will write the SQL solution for this first. Okay. With managers as tier 1, employees who manage at least one person, who manage at least one person. Select distinct EMP ID from employees where EMP ID in select manager ID from employees where manager ID is not null, where manager ID is not null. Select manager ID from employees where manager ID is not null, comma, super managers as tier 2, employees who manage a tier 1 manager. Select distinct EMP ID, comma, manager name from employees where EMP ID in select manager ID from employees where EMP ID in select EMP ID from managers. Senior managers as tier 3, super managers who do not manage another super manager. select EMP ID, manager name from super managers where EMP ID not in, select manager ID from employees where EMP ID in, select EMP ID from super managers and manager ID is not null. Final output. Not in, and manager ID is not null where employee ID in, select EMP ID from super managers and manager ID is not null. Final output. Join back to count only reports who are managers. Select sm dot manager name, count e dot empid as direct reportees from senior managers as sm. Join employees as e on sm dot emp id equals to e dot manager id where e dot emp id in, select emp id from managers group by sm dot manager name, order by direct reportees in descending order. Alright, now I will explain you this code again. Alright, we are tackling the question number 13 and it's a heavyweight from Google senior managers. Before we have a single self-referencing employee table from IDs and manager IDs are twisted together in messy organizational chart. After, we need a clean sorted list of verified senior managers and the exact count of how many managers report to them directly. The interview trap. When candidates see multi-level hierarchy problems like this, they panic and try to write complex recursive CTEs. You do not need recursion. The biggest trap here is actually hidden in the output numbers. If you look at Rick in the sample data, he manages two employees, Daigon and ID 103. But Google's output says Rick only has one direct report. Why? Because ID 103 is an individual contributor. Google strictly wants you to count direct reportees who are themselves managers. If you do a standard count, your numbers will be inflated and your code will be rejected. Explaining the code. We are going to conquer this org chart by building three clean logical tiers using CTEs. Tier 1 is our managers table. We grab any EMP ID that shows up in manager ID. If you have a direct report, you are in this bucket. Tier 2 is of super managers table. We look for employees who manage someone from our tier 1 list. This isolates people who manage managers like Rick and John. Tier 3 is where magic happens. Our senior managers table. By Google's definition, a senior manager cannot manage another senior manager. So we take our super managers list and filter with not in to eliminate anyone who manages another super manager. In our sample data, John manages Rick. Because Rick is a super manager, John gets disqualified. Rick only manages Diagon, who is the first line manager, so Rick survives. So, for our grand finale, we join our verified senior managers back to the employees table to get their direct reports. We add our crucial filters where EMP ID in select EMP ID from manager to strip out the individual contributors, group by the manager's name, order by the report count descending, and when we hit submit, okay, our solution is not been accepted. So our solution was wrong actually. So here is the solution which is submitted by Mohit Khanna. Okay, imagine a hierarchy of employees followed by the manager, followed by the senior manager at the highest level. The question is asking for the senior manager with their direct reportees, which are manager level in the hierarchy. Step 1. Self-join the employees table twice for managers and senior managers. The joint table is aliased as managers as it will represent managers table. Okay. Select star from employees, inner join employees as managers. Now we self join with employees table again, alias it as senior manager to represent senior managers table. Now all we have to do now is define the desired output, senior manager's name and direct reportees. Order the output by direct reportees in descending order. See, it was so easy, bro. Now I hit submit. This solution has been accepted. Now we move to our question number 14. Amazon server utilization time. Amazon Web question number 14. Amazon Web Services is powered by a fleet of servers. Senior management has requested data-driven solution to optimize server usage. Write a query that calculates the total time that the fleet of servers was running. The output should be in units of full days. Assumption. Every server might start and stop at several times. The total time in which a server fleet is running can be calculated as sum of each server's uptime. So we are given a server utilization table. It has columns like server ID, status time and session status. We have to output the total uptime the servers were running. So first I will write the SQL solution for this with server timeline as select server ID, status time, session status, lead status time, comma 1 over partition by server ID, order by status time as stop time. From server utilization, select round extract epoch from some stop time minus status time divided by 86400 as total uptime days from server timeline where session status equals to start. Alright, let me run my code first. Syntax error, line number 7. Partition by session status does not exist. Session, run my code. Yeah, it looks fine. Now I will explain you the solution again. Alright, we are hitting lucky. We are hitting question number 14 from Amazon server utilization time. Before we have a massive AWS telemetry log, where server start events and stop events are stored on the completely separate rows. We need to pair those events together, calculate the exact duration for every single session, and output the total fleet uptime in days. Okay, so now I'll explain you the code. Let's build this bulletproof query. We start with our server timeline CTE. To measure duration, we have to get the stop timestamp onto the same row as the start timestamp. We use lead status time, 1, making sure to partition by server ID and order by status time. Now every start row has its corresponding stop timestamp sitting right next to it in a new column called stop time. In our main query, we add a simple where start status equals to stop. This filters out the stop rows so we don't accidentally calculate the dead downtime between sessions. Now for the grand finale, flawless timestamp math. We take some stop time minus status time to get our total running interval. To convert an interval into exact whole days without losing a single second of data, we use PostgreSQL magic keyword epoch. Writing extract epoch from converts our entire uptime interval into raw seconds. Since there are 86,400 seconds in a day, we simply divide by 86400, round it off, and hit submit. You have just solved Amazon Cloud Analytics problem with absolute precision. So we start with our next question number 15, the last question. Question number 15 is this. So here is our question number 15. 3-day rolling earnings by Stripe. Okay. Assume you are given the table containing assume you are given the table below containing information on user transactions on Stripe. Write a query to obtain all the users rolling 3-day earnings. Output the user ID, transaction date, and rolling 3-day earnings assumptions. The user transactions table is complete and there is no missing days in between. Each row in user transactions table represent 1 day. User transactions example input. So we are given columns like transaction ID, user ID, amount, and transaction date. And here is our example output. We have to output user ID, transaction date, and rolling earnings 3D of 3 days. Okay. So now I will write the SQL solution for this. Select 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 user ID, transaction date, some amount over partition by user ID, order by transaction date, rows between two preceding and current row. as rolling earnings 3D from user transactions order by user ID, transactions date, transaction date. So alright, we are at question number 15. This is a classic fintech problem from Stripe called 3-day rolling earnings. Before, we have a standard ledger table showing daily transaction amounts for every single user on the platform. After, we need a clean chronologically ordered financial report that calculates a running 3-day cumulative total for every user as the time moves forward. Okay, the interview trap. When beginners hear the phrase rolling sum, they usually panic and make one of the two massive mistakes. First, some candidates try to write three separate lag functions, one for yesterday, one for day before, and add them together with plus signs. This is super messy and breaks instantly if you ever need 30-day rolling sum. Second, candidates try to use some amount over partition by user ID order by date. If you stop there, SQL uses default Windows frame which adds up everything from very first day a user joined. We don't want a lifetime total, we want a strict 3-day sliding window. Explaining the code. We can solve this problem by a single elegant select statement by unlocking a hidden superpower of Windows function, custom framing. We start by selecting our row ID. We start by selecting our user ID and transaction date. Then we set up our aggregation sum amount over inside our window function. We apply our standard foundation. We partition by user ID to build a protective wall for each customer's bank account. And we order by transaction date to line up their payments chronologically. Now for the magic line, we add rows between two preceding and current row. What does this do? It tells SQL for whatever day I am currently evaluating, reach up and grab the two rows immediately above me. Draw a box around the 3 days and sum up the amount. As our query steps down the timeline day by day, that 3-day window slides right along with it. Order our final table with user ID and date. When we hit submit, our solution has not been accepted. Here is our output, and expected output is this. Let me check the solution. Okay, if this is your first time solving the rolling sum, don't worry, I will take you through step by step solution. Objective: finding the rolling 3-day earnings for each user by transaction dates. Two-step approach. So here is the official solution. So when we copy and paste the full solution and submit it, our solution has been accepted. So I will explain you this solution again. Find the rolling 3-day earnings for each user by transaction dates. Two-step approach. Find the total earnings by user and transaction date. Get the get the rolling sum of the earnings of the preceding 2 days and current day. Step 1. The user transactions tables is recorded by individual transactions and not grouped by date. So we have to sum earnings by users for each date. The query should look something like this. Okay. The user transactions table is not recorded by individual transactions, so and not grouped by date. We have to sum the earnings by users for each date. Okay. So the output for the user 243 is this. Keep in mind, you do not need to order the results by user ID transaction date at this stage, because the above query will be converted into a CTE. Next, we will wrap this query into CTE of daily transactions to reuse the output. Then we can calculate rolling 3-day earnings using total earnings field. So here is the full solution. Let's break down the rolling sum calculation where. So here is the full solution, and when we hit submit, our solution was accepted. So our 15 hard questions from data lemur are also done. We will so I will see you in the next video where I will be teaching Python statistics in Python. So see ya, we'll see you in the next video. Bye.